Meet Mark and James. Without these two guys, the glitzy town of Las Vegas would pretty soon lose its sparkle, because it's their job to keep the city's neon signs glowing.
That's the one right at the bottom of the eye, that's bad, okay?
Their task this morning is to replace a failed neon tube. A tough job, as the tube in question is 100 meters up on the side of a hotel.
It's all about safety. Be safe and it's all piece of cake.
Fortunately, Mark and James are used to heights. They work for Yesco, one of the oldest neon sign makers in Vegas. Yesco made the first major neon sign in Vegas back in 1932 and are responsible for over half its iconic neon landmarks. The trouble is, many of them illuminate the top of Vegas's tallest buildings. So it's out with the abseiling harnesses and time to go over the top.
You have to be certified. You take a course, and you have to get recertified every 2 years.
It's a difficult and risky job. First, they have to work out which tube is blown. This isn't easy in the bright light of day, especially as the sign measures 67 meters across and contains 848 tubes. But after half an hour swinging from their harnesses, they eventually manage to locate and replace the bulb, leaving them just enough time to catch their breath before they start the next job. Creating an extraordinary sign like this requires a unique combination of design and engineering skills. So to find out their secret, we decided to ask the team at Yesco to make us one. They informed us that their biggest signs contain nearly 1 million tubes and cost up to $10 million. After we got up off the floor, we asked if they could impress us for a little less.
Hey Dave, how's it going? Got kind of a quick job we need to get out for Discovery Channel. How do they do it? Okay. Some aluminum stuff. It should all be pretty cut and dried.
I'll take care of that for you.
All right, thank you.
The first job is to put together the artistic concept on the computer. The design we settled on is going to be circular with a kind of 50s diner feel. So, with the design agreed, a computer is used to break it down into a series of lines, which will then be reproduced with neon tubes. They begin by printing out full-size templates for each of the individual parts. These are made from fire-resistant layout paper, as the process of creating shapes and letters from the glass tubes will expose them to some very high temperatures. Next, they need to shape the tubes. It took Jerry here 6 years training to perfect this delicate moulding process. He has to blow into the tubes to keep the temperature down just enough to stop the sides from collapsing inwards. That way, the glass remains perfectly cylindrical. This is vital, because when it's filled, the gas inside will only be at just 1/100th the pressure of the air outside. Any minute flaw and the tube could shatter. Meanwhile, the aluminium frames on which the tubes will be mounted are fixed in place and wired up. Back in tubes, it's time for Jerry to hand over to James. And in case you've noticed, they do indeed look alike, because they're twin brothers. Anyway, you might reasonably be expecting James to fill the tubes with neon gas, but you'd be wrong. The problem is, when you pass electricity through neon gas, it only gives off shades of red. So in order to produce other colours, the glass tubes are filled with another inert gas, argon, together with a tiny amount of mercury. When electricity passes through this cocktail, the mercury vaporizes, giving off invisible ultraviolet light. And to convert that UV light into bright, bold colours, the inside of the tubes are coated with different kinds of phosphor. Hey presto, lots of colours. Anyway, James now has to suck all the air out of the tube to create a vacuum before injecting the low-pressure mixture of inert gas and mercury. He's the real magician and artist, because it's his job to get the mixes of argon, mercury and phosphor, which coat the inside of the tubes, just right in order to produce the specified colour. But intense colour alone isn't enough to make an eye-grabbing illuminated sign, so the bulbs are also programmed to animate. Having programmed the display sequence on a computer, it's stored on a chip and installed in the completed sign. With the metal frame cut into shape and polished, it's time for a last coat of paint before our sign moves on to final assembly. A triumph of art, chemistry and computer chip technology combined.
How do they do that?